Hello, dear participants of the conference. To your attention, I show a presentation on the topic heap leaching of gold from the destructured oxidizers or of the Belsu deposit, Abay district, Abay region, Republic of Kazakhstan. Heap leaching technology is increasingly being used to extract metals from poor ores, especially in the gold mining industry, and is characterized by low capital cost compared to other methods. The long-term practice of working with, with this technology of foreign and Kazakhstan enterprises confirms the higher technical and economic efficiency. However, a big problem is destructured slimy and clay ores, which reduce the seepage of the gold dissolving solution, which reduces the extraction of gold. The purpose of this work is to develop models and indicators of heap leaching of gold from the destructured oxidizers or of the Belsu deposit, Kazakhstan, with recommendation for the use on an industrial scale. General view of the ore deposits. The gold-bearing ore of the Belsu deposit has been investigated. The technological sample is represented by two types of ores in terms of physical structure, destructured leaching crust and quartz containing strong pieces of ore, the amount of which is much less by weight. According to the results of assays the average gold content in the ore is 1.88 gram per ton. The chemical consumption of this ore is shown in the table. The industrial value in the sample is gold. All other metals are contained in insignificant amounts and are not of interest for industrial scale, industrial production. The results of the sieve analysis are next. Ore is mainly represented by fine material minus 2.5 millimeter, the yield of which various size was 73%. It can be also be noted that the large class is enriched in gold, which indicates the presence of quartz with fairly large gold. This slide shows a distribution of gold for ore of various sizes. Laboratory bottle tests were performed for preliminary assessment of gold dissolution. Laboratory studies on cyanide leaching were carried out in a bottle agitator. The leaching modes were as follows. Mass of ore sample for each experiment was 300 gram. The ratio of solid to liquid is 1:2. pH 10 from 11. Sodium cyanide concentration equal 0.1%, and the leaching duration was 24 hours. During the leaching process, the concentration of sodium cyanide and the pH of the medium were monitored, and the reagent were added if necessary. According to the results of the bottle test, we can say size of cyanide raw materials affects the degree of dissolution of gold, which increases with decreasing size. From the crushed sample, an average 94% is dissolved, and from the crushed sample with a fineness of minus 2.5 millimeter, an average of 84% of gold is dissolved. In other word, decreases by 10%. However, the performance during leaching of crushed ore is quite good, which indicates the possibility of using heap leaching process. According to the results of percolation tests, the percolation ratio of water through the ore low is many times lower than the regulated one, or without preliminary granulation is not suitable for heap leaching. The tests were carried out to work out the optimal pelletizing modes. Cement consumption was 18 kilogram per ton of ore. The picture below shows photos of pelletized ores. Then the pelletized ores are loaded into columns for leaching. The process heap leaching was carried out in a closed cycle: leaching, sorption, return of the working solution to the leaching turnover. Anion exchange resin AM2B was used as a sorbent for extraction of dissolved gold from productive solution. On next slide showed gold. The solution required 31 leaching cycles for minus 25 millimeter and 32 leaching cycles for minus 12 millimeter ore. The total amount of productive solution to achieve complete leaching was from 2.19 to 2.29 meter cube per ton. Gold extraction into the solution according to operational data, excluding washing solution, was 72%. And the next slide showed cyanide consumption was 0.47 kilogram per ton. The leaching tails were analyzed and the balance was compiled. From all gold dissolved well during heap leaching, the degree of dissolution of gold according to the balance from ore with a size of minus 25 millimeter and 12 millimeter was 74.41% and 76.57%, respectively, with an initial gold content of 1.88 gram per ton in ore, and as gold content in the leaching tailings is 0.48 and 0.44 gram per ton. Conclusions. For industrial conditions of heap leaching, it is recommended to use the ore of the Belsu deposits with a size of minus 25 millimeter with a preliminary pelletizing with cement. The developed technology made it possible to efficiently process this ore and obtain gold in the form of marketable products, the doré alloy. Economic calculation confirmed the effectiveness of the developed technology. The technology has been introduced into industrial production. Thank you for your attention and goodbye.